The first question is kind of just a logistical one on question 89. To use a binomial distribution to approximate the count of successes in a simple random sample, why do we require that the sample size n be no more than 10% of the population size n? So the reason for this is because if the sample size is small enough, when you take the samples, it won't change the numbers enough to really affect those probabilities. So you can think about the example that we did in class where we started off with 8,000 Skittles that were red, 8,000 Skittles that were not red out of 10,000, and then when we picked one out, that would give us this many left out of this many Skittles. And then when we picked another one, that would give us this many left out of this many Skittles, and we could keep going. But these honestly are so close to each other. Those fractions are all really close to 0.8. And so it's like we might as well just assume that these are independent trials and that they don't actually change every time. All right, this problem actually puts some of that theoretical stuff into action. What kind of websites do males aged 18 to 34 visit the most often? Half of male internet users in this group visit an auction site such as eBay at least once a month. A study of internet use interviews a random sample of 500 men aged 18 to 34. Let X be the number in the sample who visit an auction site at least one time a month. So the first question is asking us to determine if this is a binomial random variable. So we need to check bins. Remember, B stands for binary. And in this case it is, and the reason we need to give a reason here. They either visit an auction site once a month or don't. So it's kind of like they either do that or they don't. And I'm abbreviating a little bit here because it's kind of challenging to write. And then, the next thing is I for independent. Now here's the thing, if I'm choosing people, the pool of people is getting smaller with every person that I choose. So technically it's not independent, but it does meet the 10% condition. And so what you would need to show work-wise is, 500 that was the sample size. 500 is definitely less than 10% of all males that are 18 to 34. I don't have to have the population of males that are 18 to 24, but I know for sure there's more than 5,000 of them. So this works to say that 500 is less than 10% of all males. N is that the number of trials is fixed, which in this case it is, it's 500. S is that the probability of success stays the same every time. And in this case it does. Like they either are, they either visit it or they don't visit it. And it mentions it earlier that half of the male users in this group visit an auction site. Like that was kind of buried in there, but right here. And so P is 0.5. So yes, this does meet all the conditions to be a binomial random variable. Then it asks us to check the conditions for normal. So to do that, we need to check the law of large counts. It needs to be NP is greater than or equal to 10, which in this case N is 500 and P is 0.5. That definitely is greater than or equal to 10 because that's 250. And then we also have to check N times 1 minus P greater than or equal to 10. But in this case, 1 minus 0.5 is still 0.5. So it works. Obviously, if it was not 0.5, then I would have needed to actually subtract from 1 and do the numbers. So since this is met, that means I can use the normal distribution to do an estimate. Let's say it says estimate the probability that at least 235 of the men in the sample visit an auction site at least once a month. So you either need to find the z-score or you need to draw your sketch out with labels. So if I draw my normal thing, my mean and standard deviation I actually need to calculate. So I actually should do that over here. So the mean is going to be equal to n times p. That's the formula that we use for binomial random variables. So that means that the mean is going to be 250. And then the standard deviation formula looks like this. You can get these from the formula sheet if you want to. That should be a minus sign right there. And it ends up being about 11.18. All right, so I'm kind of running out of space. Let me move this and draw my sketch a little bit bigger here. So this is a normal curve with a mean of 250 and a standard deviation of 11.18. 250 is here. The question said at least 235, so that would be here. And at least means 235 or more. So I'm going to go ahead and shade all of the area to the right. And then I'm going to need to use either normal CDF on the calculator, or I need to use the Statlet to actually find this area. And it ends up being 0.9102. Just a side note, if you wanted to find the z-score, if you were using a table and you didn't have the technology, you would do 235 minus 250 divided by 11.18. That would give you a z-score of negative 1.34. And then you could look at the normal table. Now the normal table is going to give you the area to the left of that z-score, so you would have to do 1 minus that. And that would eventually get you to this right here. So this is the probability that z is greater than negative 1.34. Okay, don't forget, you kind of have the sketch. You have to make sure there's a label. You have to have the answer and have it like pointing to the area you're talking about. And then you need to actually put the answer in context. So the answer in context would be something along these lines. There is a 0.9102 probability and then I'm going to kind of like fill in the stuff from the problem, that at least 235 of the men in the sample, because we're specifically talking about this sample of 500, visit an online auction site. There it is. The last one is a quick one if you know what it's talking about. So it's saying, is it appropriate to use a normal distribution? So remember earlier we talked about the condition that makes it appropriate to use the normal distribution is the law of large counts, which is n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. If both of those are met, then I'm allowed to use a normal distribution. So I can just kind of start plugging numbers in and seeing if it works. Clearly, if I plug in a, 10 times 0.5 is 5, and that is not big enough. So I can cross off a. 40 times 0.88 is big enough, but I have to do both. So if I do 40 times 0.12, that would be like this one over here. That's actually only 4.8, so that's not big enough. If I check part C, 100 times 0.2 is 20, and 20 is greater than or equal to 10. So then I'll do the other one, which would be hopefully obviously correct. 100 times 0.8 is going to be 80, and that also is greater than 10. So the answer to this one was C. C is the right conditions for being able to use a normal distribution.